To know if other solar systems have the right environment to support life, we need to know how they are born and of what they are made. But how can we study the raw materials of a baby solar system?
Ideally, we would actually like to take a spaceship and just fly into, one of our interstellar clouds and take a little piece of material and then analyze it. But unfortunately, we cannot do that.
That's Ewine van Dishoeck, who won the 2018 Kavli Prize in Astrophysics for her research on the chemistry behind the birth of stars and solar systems.
So the space between the stars is not empty, but it is filled with a very, very dilute gas.
It's here, between stars, that denser interstellar clouds also form, and where a new star will be born. Van Dishoeck figures out the chemical environment of this stellar nursery by analyzing the energy patterns of molecules tumbling through the cloud.
Every molecule has its own barcode. We see this whole forest of lines, basically, that we can then compare and uniquely identify all of these different molecules.
Interstellar clouds are mostly made up of hydrogen and helium. At the edge of the cloud, ultraviolet radiation destroys molecules that form. Deeper in, dust particles scatter the radiation, allowing more complex molecules to survive.
Ultimately, if we think about the origin of life, we need water, but we also need organic compounds. And the question is, how complex can these molecules already be in these interstellar clouds before the planetary system is formed?
Van Dishoeck creates space-like conditions in the lab to investigate how complicated molecules develop. She discovered dust grains provide a place for oxygen and hydrogen to get close enough to create water, and hydrogen reacts with carbon monoxide to make methanol.
And we can even make more complex organic compounds such as glycolaldehyde, simplest sugar, and glycerol.
When the interstellar cloud collapses to create a new star, these complex molecules are left behind to become part of the dusty mix that condenses into planets, which means all of the ingredients needed for life are probably already there.
What our observations, laboratory experiments, and models have shown is that near almost every forming star and planetary system, there is sufficient water and organic material available. Now, whether life will happen there, that's a whole other question.